All right, in this video, we're going to look at understanding and using factorial notation, which is a little bit related to the fundamental counting rule that we talked about in the last video. So again, let's take a look at another example just to help introduce the idea of factorial notation. So example 2, we have a baseball lineup consists of 9 players. How many different lineups using all 9 of the players on a team exist? So let's say we only have a team with 9 players on it, a baseball team, which hopefully nobody gets sick or injured or has to miss a game for whatever reason. But just for this problem, we have 9 players and we have 9 positions to assign those players. Well, using our fundamental counting rule with 9 positions, let's say the first position is a pitcher, second maybe catcher, first, second, third, fourth, or first, second, third base, and then the shortstop and the outfield positions. So for the first position on the team, we have 9 total players available to choose from. So as far as the first position, which is usually pitcher, at least it was when I was little and I played baseball, everyone wanted to play pitcher. There's 9 players available for that position. Now, once one of those 9 players has been selected to that position, that means now for the second position, there's only 8 players left for the second position. So notice we went down by 1 because our first position's already been assigned. So out of those 9 people, we now have 8 of them left for the second position. Likewise, the third position would have 1 less player available for it, which in this case there's 7 players available. And we can continue this on all the way down to the 7th position, which there are 3 people available for, the 8th position, which there are 2 people available for, and then the 9th position is only 1 player left to play that position. So, hopefully they wanted to play that position. But now to figure out how many different lineups we can make, we can use our fundamental counting rule with 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we would have 362,880 different lineups that we can make. Now, rather than write out all the numbers from 9 to 1 and then multiply them like we had to do, even though we skipped a few in the middle here just for space, mathematicians created what's known as factorial notation to expedite the process. So the symbol for factorial notation is an exclamation point after the number. So whatever number has the exclamation point after it, we start at that number and then count down to 1 and multiply all the values from that number all the way down to 1. So in this case, 9 factorial is 9 times 8 times 7 all the way down to 1, which gives us the 362,880, which is a lot easier to put in 9 factorial than it would be to have to type all this in. So for instance, if we look at Desmos here, if I go to the keypad here and I believe it's under functions and is it stats? No, it's none of the above. Oh, it might be, yeah, it's right here. So if I wanted to type in 9 factorial, I could just hit 9 and then the keypad here, ABC, and then this button here, and there's my 362,880. So in general, for a positive integer n factorial, like 9 factorial, is n times n minus 1 times n minus 2 times n minus 3, all the way until we get down to 1. So like 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we have 0 factorial equal to 1. So we'll maybe touch upon that in the next video. But for right now, let's also keep in mind that factorials, because we're multiplying, the value is going to grow pretty quickly here. So we have 2 factorials 2 times 1, 3 factorial is 3 times 2 times 1, 4 factorial is 4 times 3 times 2 times 1. So notice each new value is just that number times the previous answer. So 4 factorial is 4 times 3 factorial. And then 7 factorial is 7 times 6 factorial. These same 6 numbers are in 7 factorial as well, and that gives us 5,040. So these values here on the right, they get pretty large fairly quickly. The next one, 8 factorial, is 8 times 5,040, which is over 40,000. So it gets pretty large pretty quick. All right, so example 3, how many ways are there to arrange 5 books on a shelf? So we have 5 books. We're just going to arrange them all. We can do 5 times 4 times 3 times 2 times 1, or real quickly do 5 factorial and get 120 different arrangements of those 5 books on the shelf. So, all right, that about does it for this video. Thank you for watching. I will see you next time.